Next is calculation of an. So an is 2 by t0 integration t to t plus t0 x of t cos n omega 0 t dt. So here t0 is equal to t and omega 0 is equal to 2 pi by t. So we can write an equal to 2 by t integration now we have the formula that cos of at dt is sin at by a, and here a is n 2 pi by t. So we can write an is equal to 2 by t 2 by t in sin n 2 pi t by t divided by n 2 pi by integration from minus tau by 2 to tau by 2. So here t get cancelled, 2 get cancelled. Okay, so it is 1 by n pi into sin n 2 pi t by now we replace these integration values here, and by solving we get 1 by n pi sin of n pi by t minus sin of now for second term in square bracket we can use, for this we can use formula, since we have sin of minus theta is minus sin theta. So we can, and here what is theta? Theta is n pi tau by t. So here an is equal to 1 by n pi sin of n pi plus sin of so an is equal to divided by n pi. So we have now a0 value. a0 is equal to 2 by n pi sin of n pi, and b0 is equal to bn is equal to 0. Now we have generalized equation of trigonometric Fourier series as this is generalized equation a0 plus summation n equal to 1 to infinity an cos n omega 0 t plus n goes from 1 to infinity bn sin n omega 0 t. Now putting values of a0, an and bn, we get x of t is equal to n is equal to 1 to infinity 2 by n pi sin of n pi cos of n omega 0 t. So this is the final equation. Now next problem is example on exponential Fourier series. Next problem is example on exponential Fourier series. So write down, determine complex exponential Fourier series. Determine complex exponential Fourier series for periodic rectangular pulse train shown in figure. So we draw this figure first. So it is this diagram is given in the problem. It is T0. So first is step 1 is calculation of Cn. So Cn is equal to 1 by T0 integration t to t plus T0 x of t e raised to minus j 2 pi and t by T0 dt. So here T0 is what? T0 is fundamental period. So here T0 is fundamental period and it is shown in the above figure. Now basic signal is from minus tau by 2 to plus tau by 2. So so these are the limits. Now amplitude of signal is A. Is A. Therefore x of t is equal to A. So Cn is equal to 1 by 2 T0 integration So it is equal to a by t0 integration so it is a by t0. Solve this integration and we get integration values. So here t0 get cancelled and t0 get cancelled. This t0 and this t0 get cancelled. So equation becomes a by n so we replace these integration values in this equation and we get Cn is equal to but we have the formula as e raised to j theta minus e raised to minus j theta divided by 2j is equal to sine theta. And here what is theta? Theta is pi and t. So we can write this equation as Cn is equal to a by pi n sine of pi n tau. This is equation 1. Okay. Now we convert this equation 1 in terms of sinc function. So we have the formula as it is equal to sinc of x is equal to sine pi x divided by pi x. So we can rearrange this equation 1 like Cn is equal to a by pi n. It is pi n tau divided by pi n tau into pi n tau. So here this term is sinc of pi tau. So this pi n and pi n get cancelled and Cn is equal to a tau sinc of n. This is equation number 2. Now next is step 2, that is magnitude spectrum. Magnitude spectrum. Now equation 2 represents the sinc function, this one, and its spectrum. For this we have to draw the diagram. It is mod of Cn. This is 0. So this diagram shows the magnitude spectrum. Now the negative magnitude can be made positive by adding phase shift of 180 degree. So we write here negative magnitude can be made positive by adding phase shift of 180 degree. And next is step 3. Step 3 is Fourier series expansion. So equation of exponential Fourier series is x of t is equal to summation n goes from minus to infinity cn e raised to minus j2 pi n t by t0. So we put the values of cn here and we get equation x of t is equal to summation goes from minus infinity to infinity a tau e raised to minus j2 pi n t by t0. So this is Fourier series expression. It is expansion, not expansion, it is expression. This is the equation. So this problem was also asked for 6 marks in the exam. Okay. Now the next problem is find out exponential Fourier series. For impulse train shown in figure. Also plot its magnitude and phase spectrum. So first we draw the given. It is x of t, it's 0, t0, 2t0, 3t0 dot dot dot. It is minus t0, minus 2t0, minus 3t0 dot dot dot. So this is given in the problem. Okay, and we have to find out the exponential Fourier series or impulse train which is given here. Now this problem was also asked for the 6 mark. So step 1 is calculation of Cn. Step 1 is calculation of Cn. So the basic signal is the pulse at t is equal to 0. So it is a unit impulse delta t. The width of delta t is very small. So we cannot calculate Cn using normal integration formula. So we will solve this numerical using shifting property of the delta function. Now this shifting property is given by the formula minus infinity to infinity x of t delta of t minus t0 dt equal to x of t 0. This is equation number 1. Now according to, we write here, according to definition equation of Cn. So Cn is equal to 1 by t0 integration t2 t plus t0 x of t into e raised to minus j 2 pi and t by t0 into dt. So this is equation number 2. Now next is compare equation 1 and 2. So x of t is equal to e raised to minus j 2 pi and t by t0, and delta of t minus t0 is equal to delta of t, that means t0 is 0. So x of t0 is equal to e j2 pi and 0 by t0. So it is e raised to minus 0, which is 1. E raised to 0 is 1. So from equation 2 we can write, from equation 2 Cn is equal to 1 by t0 into 1. So it is equal to 1 by t0. This is equation 3. Now next step is, step 2 is Fourier series expression. Fourier series expression. So putting the values of Cn in Fourier series equation, we can write equation as xt summation n goes from minus infinity to infinity by t0 e raised to j2 pi and t by t0. So we directly write the substitute the value of Cn here. Now next is step 3. Now step 3 is magnitude and phase spectrum. Magnitude and phase spectrum. So from equation 3, mod of Cn is equal to 1 by t0 and phase phi is equal to 0. Because why it is 0? Because there is no imaginary term. There is no imaginary term. So we have to draw the graph for this, that is magnitude spectrum. We have to draw now. So magnitude spectrum is, it is n, it is mod of Cn, this is 0, 1, 2, 3, dot dot dot, it is minus 1, minus 2, minus 3, here it is. It is 1 by t0. This diagram shows, this figure shows the magnitude spectrum.